Toyota spent decades building the most trusted name in automotive engineering on the planet. They invented the production system that every other car manufacturer tried to copy. They built a reputation for reliability that became the global benchmark. Tesla rewrote the rules entirely. Elon Musk built a company from nothing that became the most valuable automaker in the world. Tesla forced an entire industry to take electric vehicles seriously and pushed battery technology further and faster than anyone expected. Both of these companies have billions of dollars in research budgets. Both have thousands of engineers working on batteries specifically. Both have decades of institutional knowledge in energy storage. And both of them are now scrambling, urgently and openly, to copy a battery technology that a Chinese company developed and quietly deployed at massive scale while the rest of the automotive world was not paying close enough attention.
That company is BYD. The technology is called the Blade battery, and the story of how one Chinese automaker out-engineered two of the most sophisticated car companies in history on the most critical technology in the entire EV industry is one of the most consequential business stories of our time. Let's get into it. So what exactly is the Blade battery, and what makes it fundamentally different from every lithium-ion battery design that came before it? To understand why it matters, you first need to understand how conventional EV battery packs are structured. In a typical lithium-ion pack, the basic unit is a small cylindrical or prismatic cell. Thousands of these cells are grouped into modules. Multiple modules are then assembled into a complete pack that goes into the vehicle. This cell-to-module-to-pack structure has been the industry standard for years. The problem with this approach is layers. Every layer of packaging adds weight, takes up space, and costs money without storing any energy. A significant portion of a conventional battery pack is structural material that exists purely to hold the actual cells in place. That is wasted volume and wasted weight. BYD threw out this conventional architecture entirely. The Blade battery uses long, flat, blade-shaped lithium iron phosphate cells, and instead of grouping cells into modules and then into a pack, BYD arranged the blade cells directly into the pack structure itself, with the cells acting as structural elements rather than just contents inside it. This is called cell-to-pack architecture. By eliminating the module layer entirely, BYD dramatically increased the percentage of the battery pack's volume occupied by actual energy-storing cells. The result is a pack that stores more energy in the same physical space, weighs less, and costs less to manufacture. The insight sounds obvious in retrospect. If the module layer is just structural packaging and the cells themselves can provide that structural function, you do not need the module layer at all. But getting from that insight to a manufacturable product working reliably at commercial scale took years of materials engineering that nobody else had done. Now let's go deeper into the engineering breakthrough, because cell-to-pack is only part of the story. The chemistry inside the Blade battery is lithium iron phosphate, commonly abbreviated as LFP. This matters because the EV industry spent years dismissing LFP as inferior to the nickel-manganese cobalt chemistry used in premium EVs. That dismissal was based on one real limitation of LFP: its energy density. LFP stores less energy per kilogram than nickel-based chemistries. The industry consensus was that LFP was acceptable for low-cost short-range applications, but not competitive for premium long-range EVs. What BYD figured out, and what took the rest of the industry years to appreciate, is that LFP's disadvantages in energy density are more than offset by its advantages in every other dimension that matters. LFP is dramatically more thermally stable. It does not catch fire under abuse conditions that would cause an NMC battery to enter thermal runaway. The safety profile is so superior that the cell design can be simplified. You need less thermal management hardware, fewer safety systems, and less protective packaging. LFP has significantly longer cycle life. Where an NMC battery delivers 1,000 to 1,500 full cycles, LFP routinely achieves 3,000 cycles or more. LFP is much cheaper to produce because it does not contain cobalt or nickel, two of the most expensive battery materials. The raw material cost advantage is substantial. BYD's genius was recognizing that when you combine LFP chemistry with cell-to-pack architecture, using the structural efficiency of blade cells to compensate for LFP's energy density disadvantage, you get a battery that is competitive in range, while being dramatically superior in safety, longevity, and cost. That is the secret. Not one breakthrough, but the combination of two complementary approaches that together produce a result neither could achieve alone. Now let's put real numbers on this. In safety testing, the Blade battery has passed the nail penetration test, one of the most extreme battery abuse tests in the industry. A steel nail is driven through a fully charged cell, creating an internal short circuit. Conventional high-energy lithium-ion cells typically catch fire or explode. BYD's Blade battery cell shows no fire, no explosion, and a surface temperature you could touch with your hand. The safety difference is not incremental, it is categorical. At the pack level, the Blade battery's cell-to-pack architecture achieves energy density that is competitive with and often superior to conventional module-based packs using higher energy density cells. The efficiency gains from eliminating the module layer compensate for the lower cell-level density of LFP. Cycle life testing has demonstrated performance far beyond conventional lithium-ion. BYD claims over 3,000 full cycles with minimal degradation, which translates to well over 1 million kilometers of driving range over the battery's lifetime. Most people drive their car for 300,000 kilometers total. A Blade battery could outlast several cars. Cost per kilowatt-hour is where this gets commercially powerful. BYD has achieved battery pack costs that are among the lowest in the industry, enabling EV prices that have forced every competitor to rethink their cost structures. So why are Toyota and Tesla now scrambling to copy this? Tesla's response is one of the clearest examples of a major technology company being forced to reverse course by competition. For years, Tesla focused on high nickel content NMC and NCA chemistries to maximize range. Then Tesla began introducing LFP batteries, sourced initially from CATL, into its standard range vehicles. Tesla's own 4680 cell with cell-to-pack integration is conceptually related to the same architectural insight BYD had already commercialized with the Blade battery. Tesla arrived at a similar destination. BYD got there first and at scale. Toyota's response has been even more striking given its history of dismissing pure EVs. Toyota has announced aggressive EV plans built around next-generation battery technology, including LFP and cell-to-pack architectures that directly reflect the lessons of BYD's success. The world's largest automaker is rebuilding its EV battery strategy around principles BYD demonstrated years earlier. Volkswagen, General Motors, and virtually every other major automaker has shifted toward LFP chemistry and cell-to-pack integration. The entire global EV battery industry has reorganized around insights that originated in BYD's engineering labs. So how did BYD pull this off? The story is remarkable. The company was founded in 1995 by Wang Chuanfu, a chemist by training as a rechargeable battery manufacturer in Shenzhen. Not a car company, a battery company. Wang built BYD into one of the world's largest battery manufacturers by reverse engineering Japanese technology, figuring out lower-cost manufacturing, and relentlessly reinvesting profits into expanding capability. In 2003, BYD acquired a struggling Chinese automaker and entered the car business, a move that was widely mocked at the time. But Wang's insight was that batteries would be the defining technology of the automotive future, and a company that understood batteries deeply would have an insurmountable advantage when that future arrived. BYD's vertical integration is the foundation of everything they have achieved. Where most automakers buy their batteries from external suppliers, BYD designs and manufactures its own batteries, electric motors, power electronics, and most other critical components. When BYD's engineers want to optimize how the battery interacts with the rest of the vehicle, they can do it across every system simultaneously, without the constraints that come with working through external suppliers. This vertical integration, combined with China's massive domestic EV market and significant government support for EV development, created conditions where BYD could develop, test, and deploy the Blade battery at a speed and scale that competitors could not match. Western automakers missed this because they were looking at BYD through the wrong lens. They saw a Chinese company making cheap cars for the Chinese market and assumed it was not a serious competitive threat. What they failed to appreciate was that BYD's real competitive advantage was not in the vehicles, it was in the batteries. And by the time that became undeniable, BYD had already built an enormous lead. So what does this mean for the global EV race? The market share numbers tell a stark story. BYD has become the world's largest seller of electrified vehicles, overtaking Tesla in total EV and plug-in hybrid sales. In China, BYD commands a dominant market share that keeps growing. BYD is now expanding aggressively into Europe, Southeast Asia, and Latin America, bringing blade battery-powered vehicles at price points Western manufacturers struggle to match. For consumers, the rise of BYD and the broader adoption of blade battery principles across the industry is unambiguously good news. Competition drives prices down. The scramble by Toyota, Tesla, Volkswagen, and others to adopt cell-to-pack architecture and LFP chemistry is already pushing battery costs lower and improving the value proposition of EVs for ordinary buyers. The next decade of the EV industry will be defined by the competition between companies that have internalized BYD's lessons and those that have not. The companies that move fastest to adopt cell-to-pack architecture, LFP chemistry, and deep vertical integration are going to win on cost, reliability, and safety, the dimensions that ultimately determine which EVs ordinary consumers choose to buy. BYD did not win this round by spending more money or having more engineers. They won by asking a different question. Instead of asking how to make existing battery technology incrementally better, Wang Chuanfu and his team asked what a battery pack would look like if you designed it from first principles with no inherited assumptions. The blade battery is the answer to that question, and the entire global automotive industry is now living with the consequences. And that is the full story of BYD's blade battery, the secret technology Toyota and Tesla are desperately copying, and the engineering breakthrough that is quietly reshaping the entire EV industry. This is one of those stories where the most important things happening in an industry are not the ones getting the most headlines. While everyone was watching Tesla's stock price and Toyota's hybrid sales, BYD was building something that changed the rules of the game entirely. Now I want to hear from you. Did you know about BYD's blade battery before this video? And do you think Western automakers can actually close the gap? Or has BYD already built a lead too large to overcome? Drop your honest take in the comments below. I read every single one. If this video opened your eyes to something you were not fully aware of, hit the like button right now. It takes 1 second, and it genuinely helps this channel reach more people who need to understand what is happening in the EV industry. And if you are not part of this community yet, subscribe right now and turn on the bell notification. Every single week we bring you the real stories behind the biggest technology shifts, the ones that matter, told the way they deserve to be told. I will see you in the next one.